All right, happy Tuesday afternoon / evening. Hope you are doing well. Here we go. Lesson 324, how can I use my equation solving skills? More solving equations to solve problems. In this section, you have solved many equations. Sometimes these equations were given to you, other times they came from specific situations. You have begun to solve equations without using algebra tiles. Actually, we've been using no algebra tiles for a while now. In this lesson, you will continue to focus on how to show your work. All right, so that's going to be a big focus on this lesson is how to show the work and what we're doing here. And in fact, here's what I want you to have. On your lined paper, please everyone have lined paper, a new piece of paper per lesson. Always, please don't cram it into some other page. Please give me a new page every single time, okay? But I want you to write lesson 324 nice and big at the top, okay? I like to leave a space in between. I like to leave a line in between just to leave some space there, okay? Make it look a little better. And then problem 399, and we're going to do problem A, all right? So your paper should look pretty much like this. Now, some of you have a very neat and organized way of showing work. I don't mind if you keep doing that as long as it looks pretty close to this. However, some of you, it is a mess. And if it's a mess, I want you to focus on doing exactly how we're doing it here. I know that's going to be very different for some of you, but for the next couple lessons, I'm going to have this lined paper, and I expect to see your paper very, very, very similar to mine, okay? So here we go, problem 399. John's Giant Redwood, part 2. If you remember John's Giant Redwood, we did it all the way in lesson 312. In lesson 312, you looked at how a tree increased in height as it got older. Review the data below, and if possible, find your work for problem 310. Now, I'm not going to make you go back to problem 310. However, if you want to pause and go back and find problem 310 and actually review what we did and how we found this, you're welcome to do it. They go to it so that they can kind of show you how much you've grown and how much easier this is hopefully going to be now that we've done some practice with it, okay? So let's see, here we go. You see the number of years after planting, and this is the years after planting and the height of the tree. So what it says is, assuming the tree continues to grow at a constant rate, find a rule for the height of the tree using X and Y. Now, you should already be pretty familiar with this right here. What letter is the number of years after planting? That should be X, and this would be Y. Now, I want to give you a second and pause, and I want you to see if you can try to figure out what the rule is. So what rule would get me from 3 to 17 and 4 to 21 and 5 to 25? If not, we're going to practice it in just a second, okay? All right, so pause the video and try to get the equation. Okay, so here's what we did. I don't know if you remember, but what a lot of people noticed is that the tree seemed to be growing, look at that, 4 feet every time. 4 feet every time. And so if I worked backwards at 2, 1, and 0, at 2 it would be 13, at 1 it would be 9, and at 0 it would be 5. And the equation we came up with in class, and see if you see any connections here, the equation we came up with, y equals 4x plus 5. Now, ladies and gentlemen, those numbers are not random. We have been starting to make some connections, and hopefully you're starting to see that, okay? So 4x plus 5. Cool? All right. So on your paper, it should say, hey, y, on this first one, y equals 4x plus 5, or y equals the total height of tree, and x equals the what? X equals the years since planting. Now, do you notice how I'm writing on the line and right next to it? So this is exactly how I want you to see it, okay? And how I want you to do it. Then I'm going to leave a little bit of space here, and I'm going to put B right here and circle B. All right, so let's go to question B. In your rule, what real-world quantity does X stand for? Oh, I already just gave that away. What real-world quantity does Y stand for? Oh, man, there I was going, working ahead of you, wasn't I? So this should actually be B. So you know what? I'm going to make a weird thing here, and I'm just going to kind of erase that and say, hey, look at that. We got B over here. Woohoo! Okay, so we answered B, and yeah, let's move on to C now. Wow, that's sometimes I get ahead of myself, and that's one case I did that. Okay, letter C. John wants to know how tall the tree will be when it was 20 years after planting. Use your rule to answer this question. So here's what I expect to see. When you do this, write out the rule again. Y equals 4x plus 5, and we're wanting to find 20 years after planting. Write this down. Write everything down that you see here. Now, and if I'm going too fast, you're always welcome to pause and copy this down and then go from there. Okay, unpause when you're ready. Years after planting, that's X, and it's 20 years. That 20 is going to replace the X. So on the very next line, look at that, on the very next line, I go 4 times 20 plus 5. This is the big one. This is where I need you to write things down just like I'm writing them here. Yes, I want you to put it every single line, no skipping lines. So that means some of you are going to have to write smaller, some of you are going to have to write neater, but I want you to write it on every single line. Then, order of operations, what do I do next? And do you notice how I'm bringing down the y equals every single time? Order of operations, I multiply next. So 4 times 20 is 80 plus 5, and then final 85. And I circle my answer. So, the tree will be 85 feet tall. The tree will be 85 feet tall. That is what I expect to see on your paper. So have it written down, please. Okay? We used our equation. We plugged in the 20 for the number of years since planting, and then we solved. Okay? And that's question C. Now, let's see what's next. Letter D. The tallest tree in the world, the Montgomery Woods State Reserve in California, is 367 feet high. John wants to know how long it would take for his tree to get that tall if it keeps growing at the same rate. Write and solve the equation you could use to answer John's question. Be sure to check your solution. Okay? Now there's a couple things to point out. First of all, look at the facts. 367 feet high, okay, grows at a constant rate. Write and solve an equation you could use to do it. Write and solve, and then be sure to check your solution. Ooh, there's a lot to this one. So, 367 feet tall, right? So let's go to it. Let's write it down here. So this is letter D. See, I'm going to leave a line here. Okay, letter D. Circle it. 367 feet tall. We write down the facts. Okay, and what letter would that be? That would be Y, wouldn't it? So now I'm going to skip a line here just for a little bit of room here. Y equals, and our equation was 4x plus 5. And now the 367 takes over for the y, okay? 367 equals 4x plus 5. Now, if you want to, pause the video and try solving it. If not, I'm going to do it right here. So if you want to try to solve it, pause it. When you're done, unpause and follow along with me. Otherwise, you can keep going with me, okay? All right, so here we go. Since x is over here, I want to keep the x over here. I want to get rid of everything else. So the first thing I'm going to get rid of is subtract 5 from both sides. I get 362 equals 4x. And then I need to divide both sides by 4. And divide both sides by 4. 362 divided by 4. Ooh, I don't have that off the top of my head, so let me check here. 362 divided by 4. I'm helping you out here. X equals 90.5 equals X. Circle the answer. So, the tree would take 90.5 years. Okay, does not need to be a whole number. That is okay. Does not need to be a whole number. Now, you know what though? We're not quite done because the second part of the problem, I almost forgot it. The second part is make sure you check your answer. So what that means is I plug it back into my equation, this time for x, and let's see. Y equals 4 times 90.5 plus 5. I multiply this, and 40 times 90.5, oh, I have it right over here. So, but I do it again, so try it again. 90.5 times 4 would be 362 plus 5, and y equals 367, which is the answer I had at the very beginning, 367 feet tall. So that in blue is verifying your answer. Plugging in the answer you got into the original equation and solving to make sure you get the right answer, okay? All right, awesome. Cool. Last thing, did you use algebra tiles to solve the equation in part D? Would it be easy to use algebra tiles to do so? Why or why not? Now look at this one here. I'm not going to necessarily answer this one, but just look at it. Imagine doing this with algebra tiles. 4x plus 5 equals 367. Seriously? Yeah, no, we don't have 367 tiles. But it's the same process. It's just using algebra instead of using tiles to find the answer. Okay? All right, so that is problem 399. That is actually where we're going to stop for today, okay? So that's all we're doing today. Tomorrow we're going to pick up on this. We're going to continue this on the same piece of paper, and we're going to keep working on our neatness, going to keep working on how to solve equations using algebra and getting better at that skill, okay? All right, so thank you very much for watching. I will see you tomorrow.